Fine. Thank you very much.
You're welcome.
I'm very grateful for the invitation to speak at this meeting. I'm sorry you can't see me as well as hearing me. I'd like to start with a couple of photographs that I took, very poor, grainy photographs, in 1990 when I visited Charles Darwin's family home in Kent in England, called Down House. We have on the left the exterior of the house, and on the right a shot of Darwin's study, showing a chair in which he often wrote and his globe, and on the table some of the specimens that he collected on his travels. I say I visited his home. It was more like a pilgrimage. Most British people admire Darwin, but I particularly admired him because I was then a student not only of psychology, but also of evolution. At that time, in 1990, the phrase evolutionary psychology was very rarely used. But shortly after visiting Darwin's house, I got to know and to greatly admire the work of Leda Cosmides, John Tooby, and Steven Pinker. Now, from the perspective of someone like me, a cognitive psychologist, rather than a psychologist interested in sexual or reproductive behavior, these were the founders of evolutionary psychology, and they did something very important, which was to bring two major explanatory frameworks together, Darwinism on the one hand, and on the other, computational psychology, the approach to explanation in psychology which regards the mind as software running on the brain. And they introduced, in particular, the concept of an innate module, or as Steven Pinker called it, a cognitive instinct. That is a piece of software that has been shaped by natural selection to perform a particular adaptive task, and which is genetically inherited by each newborn human. Now, they focused on two cognitive instincts, social exchange reasoning, which Cosmides and Tooby argued was an adaptation for reciprocal altruism, that it was a cognitive instinct which enabled individuals to detect and enforce fair dealings in cooperative endeavors. And Steven Pinker, of course, worked a great deal on language and adaptation for communication. But those didn't remain the only cognitive instincts for very long. This was a very exciting time, and people soon were claiming that there were many other innate modules or cognitive instincts, that many distinctively human cognitive mechanisms were, in this sense, in our genes. So beyond social exchange, reasoning, and language, there were things like maths, teaching, imitation, mind reading, which is what I will call the capacity to ascribe mental states, thoughts and feelings, or beliefs and desires to other people, mental time travel, the capacity to think about episodes in the past and to plan the future, mental mapping of the spatial inanimate environment, selective or strategic social learning. In case you can't see my cursor, we're going around this slide in an anti-clockwise direction. Causal cognition, moral or normative reasoning, and metacognition. So in all these cases, there have been prominent claims that these are forms of cognition which are found in all adult humans and which are present only in a shadowy form or not at all in other animals, and the claim that they are present in adult humans because humans genetically inherit a genetic program for the development of these capacities. So people took to the Cosmidi tubi pinca kind of evolutionary psychology with enthusiasm. But in subsequent years, a number of empirical problems have been identified. And I will give several examples of these empirical problems because it is these problems that motivate the change that I'm going to advocate later in the talk from the original or classical evolutionary psychology to what I'll call cultural evolutionary psychology. So in looking at the empirical problems, let's start with the founding cognitive instincts. First, social exchange reasoning. So the strong evidence in support of the idea of social exchange reasoning as a cognitive instinct came from experiments like the one I'm about to describe, in which it was found that people were much better at conditional reasoning when the problem was given to them in terms of a social exchange than when it was given to them in an abstract way. So in this 4-card problem, people are presented with 4 cards which have letters and numbers on them, and they're asked, which cards must you turn over in order to test the rule that if there is a vowel on one side of the card, then there should be an even number on the other side of the card. When the problem is posed in this abstract way, most people realize that they must turn over the card which bears a vowel, the E in this case. But many fewer people realize that they must also turn over the card which has an odd number, 7 in this case. However, if the logically identical problem is rendered in social exchange terms, if a person is drinking alcohol, then they should be at least 18 years old. And if we have beer, Coca-Cola, under 18 and over 18 on the cards, then people are much better at spotting which 2 cards they must turn over to test the rule. So this was the major plank of evidence in support of the idea that social exchange reasoning is a cognitive instinct. But as early as 1989, Cheng and Holyoake challenged this interpretation and suggested that people are simply better at conditional reasoning problems where they have had practice on that kind of problem. So they were suggesting that the superiority was due to learning rather than to a genetic adaptation. And they produced evidence in support of their alternative account of the development of conditional reasoning by showing that there is also an advantage when the rule has nothing to do with a social exchange, but it's precautionary. So, for example, the rule might be if a gun is in the house, then it should be unloaded. Or if you're working with toxic gas, then wear a gas mask. So that's the first of the 2 founding cognitive instincts, which early encountered empirical problems. The second, language, is of course a vast subject, but there is now a very large body of evidence, much of it from our previous speaker, Mike Tomasello, suggesting that language is not a cognitive instinct. One study to which I'll draw your attention from others, not Mike Tomasello, is by Kidd and Archuli, who wanted to test the idea that children learn language not guided by a universal grammar, but by a domain general capacity for sequence learning. And in their study, they gave children two kinds of problems. In one sort of problem, the child had to learn the order in which aliens entered a spaceship. These were 6 to 8-year-old children. And in the other task, they were shown two pictures and asked, where is the mouse that is kissing the chicken? And what Kidd and Archuli found was that the better children were on the aliens task, which taxed domain general sequence learning, the better they were on the grammatical task, the more likely they were to point to the picture on the right when asked, where is the mouse that is kissing the chicken? So this is one example of the many studies questioning the idea that there is a dedicated cognitive instinct guiding language learning. Oh, incidentally, at the bottom of this slide, as on subsequent slides, I give you a reference to the particular study that I'm using as an example, but then also to work in which I have discussed the literature on the topic much more generally. Okay, so those are the founding cognitive instincts. Let's look at some of the others. Let's take mind reading, the capacity to ascribe mental states, thoughts and feelings, beliefs and desires to others. The main reason why people argued that this was a cognitive instinct was because it was believed that the capacity to ascribe mental states developed in the same order in all children across the world. But Amena Shahayan and her colleagues tested children in Australia and Farsi-speaking children in Iran and found that this was not true. Mind reading does not develop in an invariant sequence. So the children in Australia, like those in the United States, would first come to understand what's called diverse beliefs. They would come to understand that people can believe different things about the same question, and those different opinions might, any one of them, be true. Then later, they came to understand that if you have seen something, you're likely to know about it. And if you haven't seen it, you're likely to be ignorant. But the children in Iran, like children tested in another study in China, tended to understand knowledge access first about the relationship between seeing and knowing, and only later came to understand that people can have different beliefs about the same thing. What about morality? The major support for the idea that moral reasoning is a cognitive instinct came from a study in 2007 in which infants younger than a year old, about 10 months old, saw geometric shapes moving up and down a slope. So they saw a yellow triangle moving a red circle up a hill to the top. And they saw a blue square moving a circle down the hill to the bottom. And according to that foundational study, when these infants were then presented with a choice between the yellow triangle and the blue square, they would look longer at the triangle and they would reach out to touch the triangle more often than they would reach out to the square. And this was interpreted as a sign that these infants less than a year old were ascribing intentions to the geometric shapes. They thought the yellow triangle was trying to help and that the blue square was trying to hinder or get in the way of the red circle. and that as a consequence, they approved more. They gave moral approbation to the triangle rather than to the square. Now, this really would be a very striking finding. There were subsequent problems in replicating that result, and a very recently published study in 2025 tried to resolve the question by having many laboratories work on it simultaneously. They tested more than 1,000 infants, and they tested them on the original problem shown in the rectangles at the top of the screen, and in a version of the problem where the infants were not encouraged to ascribe intentions to the shapes because the red circle did not have eyes on it. And what they found was that the infants were indifferent. They were equally interested in looking at the triangle and the square, both when the circle had eyes in the social condition and in the non-social condition. 49% preferred to look at the triangle. In the social case, 55% preferred to look in the non-social case. So that major plank of evidence in favor of the idea that morality is a cognitive instinct has given way. It's very similar, and this is my last empirical problem, but it's very similar in the case of imitation. The major source of evidence for imitation as a cognitive instinct came from reports first published in the late 1970s that newborn babies will imitate a range of facial expressions, including tongue protrusion, mouth opening, and lip pursing. There have been recurrent difficulties in replicating this result, and in 2016, Oostenbrock and her colleagues attempted to resolve it by testing 100 babies for imitation of 9 actions, and they tested them at 1, 3, 6, and 9 weeks after birth. And across all, they found no evidence at all of imitation. Now, many cognitive psychologists conclude from these empirical failures that we should abandon evolutionary psychology, that Darwinian thinking and the computational view of the mind cannot be satisfactorily brought together. But I disagree. I think we can preserve many good things about classical evolutionary psychology if we take a turn and make it cultural evolutionary psychology. Cultural evolutionary psychology replaces the concept of cognitive instincts with that of cognitive gadgets. It suggests that distinctively human ways of thinking are not like organs of the body, the heart, the lungs, the liver. Organs of the body are shaped by natural selection. The cognitive gadget or cultural evolutionary psychology idea is that distinctively human ways of thinking are more like early pieces of human technology or instruments, things that have been shaped by cultural selection rather than by natural selection. That they're analogous to things like canoes, traps, spinning wheels, and crossbows. Sorry, I paused because I got a request to activate my camera again, but it's still not working. Let's look a little more closely at the contrast between classical evolutionary psychology and cultural evolutionary psychology, the instinct and the gadget view. They can be contrasted in terms of what they say about development and in terms of what they say about evolution. So classical evolutionary psychology gave a relatively minor role to experience or learning in the development of distinctively human cognition. It suggested that experience evokes or triggers the development of a genetically inherited program. And it claimed very clearly that the genetically inherited programs are adaptive because they've been shaped by natural selection to solve adaptive problems. On the other hand, cultural evolutionary psychology assigns a dominant role to experience in the development of distinctively human cognition. It suggests that distinctively human ways of thinking, mind reading, imitation, language, and so on, are constructed from old parts through social interaction in the course of childhood. The old parts are genetically inherited ingredients which we share with other animals. So social interaction reconfigures these old parts into new ways of thinking. And the cultural evolutionary psychology view is that these distinctively human ways of thinking do a reasonably good job. They help the individuals who have them and their societies to thrive because they've been shaped not by natural selection, but by cultural selection. Now, people use the term cultural selection or cultural evolution to mean many different things. So let me be clear using this diagram at the bottom of the slide. In the sense in which I'm using the term cultural selection, it does not work by improving fertility. So here on the left of the diagram, we have orange circles and blue circles that represent, for example, different ways of mind reading, different ways of inferring the mental states of others. The biological children of people who mind read in the orange way and in the blue way do not differ in fertility. If we look at the middle of the diagram, each of the individuals represented has two biological offspring, just two biological offspring represented by the grey circles. There's no difference in fertility between orange and blue. But the people who mind read in the orange way attract more learners than those who read minds in the blue way. They attract more young people in their society who learn how to read minds from them. They have two or three students, as it were, whereas the people who mind read in the blue way have one or two students. And consequently, the orange way of mind reading spreads through the population. This cultural evolutionary psychology emphasizes learning, and particularly the power of social learning in the development of distinctively human cognition, but it is certainly not a blank slate theory. It argues that natural selection has changed the mind in very small quantitative ways, but ways that make us more receptive to information from other people. And it's through those changes that we are able to download cognitive gadgets from the members of our society in the course of childhood. So the suggestion is that natural selection has slightly altered our temperaments, making us more socially tolerant and more socially motivated. It's adjusted our attention, so we're especially interested in faces and voices, and it's expanded our domain general cognitive capacities for associative learning and executive control. One way of capturing what cultural evolutionary psychology is suggesting is to say that it is arguing that all distinctively human cognitive mechanisms are like literacy, the capacity to read and write. Now, literacy, of course, first appeared in the world not far away from where some of you are listening to me in Tehran. It was first invented only about 5,000 years ago. And it's generally agreed that that is not long enough for natural selection to have produced the dedicated cognitive mechanisms which allow us to read and write. Instead, we become literate through social interaction with other people, through example and teaching. And that is what cultural evolutionary says is true of all the other distinctively human cognitive mechanisms. This view suggests that distinctively human cognition is, to put it in a slogan, fragile and agile. It's fragile in the sense that if a distinctively human way of thinking were to be wiped out by catastrophe, global war or pandemic or climate catastrophe, then it would be gone. We don't have the genetic programs for the development of distinctively human modes of thinking safely tucked away in our genes to spring up again in each new generation. On the other hand, and I think more optimistically, it suggests that distinctively human cognition is agile. Cultural evolution can be a lot faster than natural selection, suggesting that our minds are not of the Stone Age trapped in modern skulls, but rather they are adapted to the recent history of the society in which we live. Now, in this final slide, we see Darwin on the right, sitting on the veranda of his house, Down House, which we see on the left. And this photograph was taken very shortly before Darwin died. And it was 10 years after he had written in The Descent of Man, the survival or preservation of certain favored words in the struggle for existence is natural selection applied to language. Now, like many others, I take heart from that. It suggests to me that Darwin would not have disapproved of cultural evolutionary psychology, that on the contrary, the great man could already see the power of cultural evolution. Thank you.